Okay, so for the back, they just get a little more difficult. Let's do a couple together. 7 is exactly what I was talking to you about. So even though we're starting with a less than or equal to, we can't decide if it's going to be an and inequality or an or inequality until we've isolated the absolute value. So this, if that's like what you're going on, is if I start with this inequality, then I shade it a certain way. You can't use that rule until the absolute value is isolated. So we're going to divide both sides by -10. And now I get a 2r minus 1 is greater than or equal to 6. Okay? So now that my absolute value is isolated, this is a greater than. That should give me an or inequality. So if that's the way you want to do it, you really could just find your two solutions and then shade on the outside because it's a greater than. So see if that helps you. If it doesn't, then you just have to do it the long way. Okay, so we're going to keep it greater than or equal to 6. We're going to switch. Less than or equal to -6. Okay, so 2r minus 1 doesn't change. I'm going to add 1. Divide by 2. R would be greater than or equal to 3.5 for the first case. Okay, like I said, keep it a decimal. It's easier to graph. Then I'm going to add 1. That's -5. And divide by 2. R is less than or equal to -2.5. Okay, so what I'm meaning with the whole look at the inequality is I have greater than or equal to. That should be an or. Then I know my solutions are at closed circles at 3.5 and -2.5. So if I go to 3.5, close my circle, and -2.5, close my circle, these are either going to be shaded on the inside or the outsides of your solutions, okay? So if you kind of understand that, you can just say, oh, it's a greater than, I better shade like an or on the outside. If you don't get that, then you just have to use your arrow trick every time. So 3.5 should be greater than, and -2.5 should be less than. Okay, so either way, it'll work. All right. Negative infinity to -2.5 union 3.5 comma infinity is that interval notation. Okay. So let's do number 9. I'll try to explain that again. Okay. So even though we're starting with a greater than, let's not evaluate until the absolute value is isolated, okay? So let's subtract, subtract 7 first. Okay, remember SADMAP, we subtract or add before you multiply or divide. Okay, and now divide by 6. Okay, this absolute value does not break up. You keep it there. Okay, that doesn't get divided by 6, just the outside does. So it'd be -5n is greater than 5. Oops, sorry. Okay. And now we have to do keep it, switch. So we're gonna, let me do that to the side here. We're gonna keep it greater than 5, and then we're gonna switch less than -5. Okay. The absolute value of -5n, or sorry, just the -5n, that doesn't change. Okay. So for keep it, we're going to divide by -5. And my n will change now to being less than -1. That's one solution. Okay, and so for switch, we switched the inequality and we switched it to negative. And so n is greater than positive 1 here. Okay? And so like I was saying before, you could just go to, okay, 1 has an open circle, negative 1 has an open circle. I started with a greater than before I made my 2 cases. So that's an or, which means an outside inequality, okay? If that does not make sense to you, just use your arrow trick. 1 is shading to the right, and negative 1 is shading to the left, okay? Whatever works for you. So negative infinity, negative 1, these both need parentheses, union, 1 infinity. Okay? All right, let's try one more. Yeah, let's try 8 because we have a negative with our k. You know what? I want to try 10. 10 looks a little bit more steps. Okay, so let's do 10 together. Okay. Focus. There we go. Okay, so isolate the absolute value before you start looking at the inequality if you're doing it that way. So we're going to add 1. Negative 4 times the absolute value of x plus 9 less than or equal to negative 20, then divide by negative 4. So x plus 9, the absolute value, is going to be greater than or equal to 5. So that just changed right there. Okay, even though it looks like a less than at the beginning, it's now greater than or equal to once it's isolated. So we should have an or inequality. Okay, so let's do keep it greater than or equal to 5. And then we'll do switch, switch, less than or equal to negative 5. All right, we'll solve each of those. Okay, subtracting 9 to both sides, we should get x is greater than or equal to negative 4, and x is less than or equal to negative 14, and our number line here has now shifted, so it should include our answers. All right, negative 14 gets a closed circle, negative 4 gets a closed circle. We have a or because this is greater than, so it should be shaded on the outside. Okay, or use your arrow trick. That's negative infinity to negative 14, closed, around negative 14, and then union, closed, or bracket, negative 4 comma infinity. Okay? All right, the rest of these are you try if you need more practice. Okay, so just these 3 on the back and the 2 on the front, and all of the top needs to be done for your notes to be complete.